Greetings, this is Unit 5, Module 1, Session 6. The name of this home connection is Protractor Practice. It's a 2-pager. Please put your name and number at the top. Get credit for all that hard work. Protractors help us measure angles. Here's a picture of one. Here I have a protractor. It's a clear one, but you can see it's very similar, right? Very similar in design. And if you read circumference, then you know that this is like the cool protractor item that he used to help solve his quest when you were reading Circumference and the Great Knight of Angle Land. Does the exact same thing. I've got the measures of the angles on it, but here's the issue. It says, when you measure an angle, you usually have to choose between two numbers because protractors are designed to measure angles that start on the right or start on the left. There are two angles to measure in each of the problems on this sheet and the next. The angle on the left is side A, the angle on the right is angle B. Find and record the measure of both angles in each problem. Now, I am going to zoom in quite a bit so that we've got a full screen image of what we're trying to measure here. Follow this line. See the arrow here? This is the point where they all touch. I've got an array that moves this direction, and then my straight line continues that way. So when it's talking about angle A, I'm trying to measure that angle, right? It's an obtuse angle. It's more than 90 degrees. But on the other side, where that letter B is, I have a smaller angle that's formed. This one right here. Okay, so maybe you can think of it as like the blue angle and the pink angle, A and B. Okay, when you're reading a protractor, you start at the 0 where the flat line is. So here's my flat line, which means I'm measuring angle A, and as I move up, I start at 0 and the numbers get higher. In order for that to happen, I can only read one set of numbers, and in this case, I need to read the top row of numbers because the top is where 0 is, and then the numbers get bigger as I go around to where it ends. If I started on the bottom, that says 180, 170, 160, 150. That doesn't make sense because I'm opening this angle up. I'm measuring how big it is. So we want the numbers to increase. So I'm going to read the top numbers until it stops about there. And I have to choose. Is that 25 or is that 155? Well, we know that this angle is getting bigger, so I'm reading the top row. So that has to be 155 degrees. Now, if I look at the B section, once again, this flat line starts at 0. The 0 is the bottom number, so I'm going to ignore the top numbers and go up 10, 20, and that's halfway in between, so that's 25. So this angle is 25. And visually and numerically, this should make sense. 155 is bigger than 25 by quite a bit. And if I look at these two angles, the A angle is bigger, way bigger than B. So it would make sense that this one is 25, but this is 155. Okay? Same thing down here. If I look at A versus B, and the colors help me, so I'm just going to use it just to keep my mind on track. Ooh, I wish I wouldn't have crossed the line there, but that's okay. And then I'm going to do the same thing with my blue. Okay, two angles, blue angle, pink angle, A and B. Once again, when I start on the flat portion of my protractor, I'm trying to start at 0. Where is 0 here? It's the top number, so I'm going to ignore the bottom numbers. Follow it, 10, 20, 30, 40, 50, 60, 70. A is 70. The B angle, follow it out to the 0. Oh, and the 0 is the bottom number, right? Follow the bottom numbers, 30, 40, 50, 60, 70, 80, 90, it doesn't matter, 100, 110. Once again, numerically and visually, this should make sense. 70 is smaller than 110. Guess what? A is smaller than B. 2 more. Take a look at this. I bet you're seeing that this is sort of a trick question, isn't it? Because regardless of whether you think of A as pink and B as blue, you're going to get what? Hopefully the same answer. Let's find out. Follow your pink line to the 0. 0 is the top number. Count the top numbers until you get to the angle, to the ending angle. Ends at 90. So I write 90 degrees. Follow the blue out to 0. 0 is the bottom number. 10, 20, 30, 40, 50, 60, 70, 80, 90 again. They're both the same. Why does that make sense? Because 2 right angles, if you think of these as right angles, because they make squares, a right angle and a right angle make a flat line, 180 degrees. This last one I'm going to ask you to do on your own, but I am just going to point out a couple things. Number 1, which angle is smaller, A or B? You should know that as you go into the question. Visually, it looks like A is smaller than B. So if you're thinking A is smaller and B is larger, I agree. So when you determine your answer, make sure you compare. Is the number that you write in A smaller than B? That's going to help you verify your answer. Zero it out, top numbers as you go up. Then when you do the B side, 0 is the bottom number, follow the bottom numbers up to the number. Okay? I'm going to let you do that one on your own. Last but not least, oh, and by the way, pause this video if you need to. There's nothing wrong. You don't have to wait for this video to finish to do your question. Pause me whenever you want. And if you know the answers, skip ahead, right? Go back and add each pair of angle measures in problems 1 through 4. What do you notice? Why do you think it works this way? So you go back. Like, let's say you go back to this question. Add both of them together. 155 plus 25. I add them both together, I get 180. Okay? I go to this one that we did, 70 and 110. Add them together, I get 180. We already did 90 plus 90, or at least we talked about it. 180. And I bet you can guess what happens when you add those two together. What do you notice? I'm going to let you write down what you notice. Why do you think it works this way? It has to work this way because we're using a protractor on a straight line. So we know that one line goes from 0 to 180. Which means that no matter how we cut this angle, okay, no matter where we put that, we're still going to get half a circle no matter what. And if you want to put that in there, you totally can. We know that half a circle is 180 degrees. So no matter how I split it, I could even split it up into a whole bunch of different sections. Still, if I add up all of that half circle, it will always be 180 degrees. And I'll let you put that in whatever wording you want. It doesn't have to be super technical. Use whatever is convenient in your brain right now. If you want to talk about the line being flat, it's a flat angle that's divided, you could. You could talk about it being half of a circle. It's always half a circle. Protractors measure half circles. They measure less than that too, but it's always going to be half a circle, which is why, like in our story, we went from 0 to 180, and that was it. Okay, because that's half a circle. Okay. If you have questions, make sure you ask a trusted adult, a math wizard, a math friend. They love to answer questions about math. So don't be afraid to ask, okay? Thanks a bunch. Check you later.